Hi, welcome back to Moose in Chemistry. This is SI Units Density Problem Lesson 4. In this problem, what we're going to do is we're going to look at if we take a known density of a known material and we say we cut that material in half, would that change the density? Alright, let's look at our problem. Planck, being a self-conscious of being the only wood at the pool to wear a life vest, decides to have his friend Timmy to cut him in half and see if changing his mass and volume will alter his density so he can float like the others without wearing a life vest. Planck originally has a mass of 122 grams and a volume of 40 milliliters, which gives him a density of 3.05 grams per milliliter. After being surgically altered, his new mass is 61 grams and new volume is 20 milliliters. What is his density, and is it different from the original density, and now will he float? Well, let's look at this. Originally, Planck had a mass of 122 grams, and he originally had a volume of 40 milliliters. Well, when you do the density formula, you take 122 grams, divide it by 40 milliliters. That gives us a density of 3.05 grams per milliliter. So at that density, there's no way he would float because the density of water is 1.0. Well, Timmy cut him in half, right? So if we cut the material in half, does that actually change the density? Let's find out. So his new mass is 61 grams, and his new volume is 20 milliliters after being surgically altered, right? So we go D equals 61 grams divided by 20 milliliters. And his density becomes 3.05 grams per milliliter. So that's the new density with the new mass and volume. But look, it's not different. So no, it's not different from the original. So that means if you cut something in half of the same material, it's still going to retain its density. And another thing, will he float now? Absolutely not. Planck would absolutely sink if you put him in water without a life vest, because Planck is at least 3 times more dense than the density of water, which is 1.0 grams per milliliter or grams per cubic centimeter. Well, if you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Moose in Chemistry!